Welcome to this class. This is a continuation part 2 of the square root and cube root. So today we're looking at the cube roots part of it. Now for cube root, we say numbers can be cubed by raising them to the power of 3. Numbers can be cubed by simply raising those numbers to the power of 3. So if you raise 1 to the power of 3, you certainly go to get 1. 1 to the power of anything will still give you 1. But if you raise 2 to the power of 3, you will get 8. You will not get it 6. Most students, they will write 6. It's not 2 times 3. It's 2 to the power of 3, meaning 2 times 2, 2 times 2 times 2. You're going to multiply 2 3 times. 2 times 2 times 2. Then you will get 8. Okay? Then if you raise 3 to the power of 3, the answer is not 9. If you say 9, it means you're a novice. It means you don't know what we mean by power. This means 3 multiplied by 3 multiplied by another 3. 3 multiplied by 3, that gives you 9. Multiplied by another 3, that gives you 27. So these are squared, cubed numbers. So if we ask you to list cube numbers, 1 is a cube number, 8 is a cube number, 27 is a cube number. If I cube 4, I'm not going to get 12. Okay? This is going to be 4 times 4, 60, times another 4. That will give us 64. So 64 is a cube number. Although it's a square number, it's also a cube number. Then if we cube 5, you will get 5 times 5, that's 25. Multiplied by another 5, that will give us 125. So you can see these cube numbers. Okay, you can see this cube number as a playing out. If you cube 6, you're going to get 216. If you cube 6, you're going to get 216. Right? So this is what it is. This is what it is. And cube numbers will be taking this order and this format. And we're going to find how this is being used. So if we say 3, if you cube, when 3 is cubed, you get 27. When you find the cube root of 27, you get back 3. So how do you use cube to find cube root? How do we use this concept to find cube root? How can we find the cube root of 27? How do we find the cube root of 27? So to find the cube root of 27, you know you got to draw like square roots. You put 3 here, small 3 here, and you put 27 inside. This is like, okay, you'll be told to find the cube root of 27. So what this means is that, first of all, I will break this 27 down. I'll break this 27 down, okay, by saying 27 means 3 times 3 times 3. So for cube root, when you break it down, you will take out of 3, you will take only 1. For square root, if you break it down, out of 2, you take 1. You remember how we find square root? For example, if you want to find the square root of 16, we say you break 16 down, you get 2 times 2 times 2 times 2. Right? So out of these 2, you take only 1, 2. Out of these 2, for square root, you take only these 2. So you multiply these 2 and these 2. 2 times 2, you get 4. That's why the square root of 60 is 4. We get 4, okay? For cube root, we are not categorized, we are not joining 2, we are joining 3. It's 3. It's 3 concept. Look at it here. It's 3. Out of 3, you take only 1. So that's why the cube root of 27 is only 3. That's why the cube root of 27 is only 3. Are you with me? So we're going to use it to find big numbers. Remember, cube root of 27, this can also be written like this in the indices. This 27 is same and saying, instead of writing the root, you can say it's 27 raised to the power of 1 all over 3. You know, for square root, we say raised to power 1 all over 2. You can also do like this, 27 raised to power 1 all over 3, which could be 3 to the power of 3. You know 27 is 3 to the power of 3, meaning 3 times 3 times 3. So 3 raised to the power of 3, then multiply by 1 all over 3, this power, 1 all over 3. This 27 is this one. This 27 is this 3 to the power of 3. Then multiply by 1 all over 3. Multiply by 1 all over 3. You see why the answer is 3 if you follow this indices way. Okay? So 3 is like you're saying, what this one means, this one here, what it means is 3 multiplied by 1 all over 3. The 3 at the bottom will cancel the 3 at the top. So it will be 3 raised to power 1. And 3 raised to power 1 is equal to 3. Is equal to 3. Because look at it. 3 times 1 all over 3. If you do like this, 3 times 1 over 3. This 3 will cancel this 3. 1 times 1 is equal to 1. So that's why we have this 3 raised to the power of 1. And which is equals to 3. That's why the cube, if you use indices method, you still get 3 as the cube root. Okay, if you use the prime factorization method, you still get the root as 3. So whichever method we use, we still get the root as 3. The cube root of 27 to be 3. We still get the cube root to be 3. Is that okay? Now let's take a look at some problems. Okay, there are some problems that numbers that will be given to you, you may not be able to find the cube root straight away. Okay, you may not be able to find the cube root. Some properties of, okay, you may not be able to find the cube root or square root straight away. Okay, now let's take a look at some properties of square roots and application uses sword notation. Okay, square root and cube root, some properties. We already established that A, B, if you have two numbers, let's say this is 2 and 4 or 2 and 5, when you have two numbers together, B multiplied can be broken as you can separate the roots. You can find the roots, the factors as root A times, you can separate them like this times root B. We've looked at something like this, one of the properties. Okay, we looked at this as one of the properties, where as long as A and B they're greater than 0, as long as these numbers are greater than 0, okay, maybe 1, 2, 3, any number greater than 0, okay, then this rule holds, rule number 1. So if you have let's say 6 has a factor, right? For example, 6, what are the factors? Is 2 times 3, right? These are the factors of 6. So if you have it this way, what we are saying is that you can write it like this. Root 2, you can split the root. Root 2 times root 3 times root 3. This aspect is called sword. We're going to describe it now, sword. So you can break it down. This rule 1 for square root and cube root, rule properties, rule 1 is saying that A times B together, the root of A and B together, okay, can be split as root A times root B. You separate them. If they're together, you can separate them. Okay, another rule is that if you have the square root of, let's say, a root of A, let's say this is number 2, root 2, this is root 1, okay, arrow 2, let's say arrow 2 for root 2. So to reduce what we are writing, if you have root A, B multiplying M plus N, for example, in a bracket, M plus N in a bracket, so this will be equal to this root A, this will be equal to, if you have this root, this will be equal to root A times M, which is root AM plus root A N. This is another rule, root A N. This is another rule, okay? This is called the second rule of sword, or second rule of square root and cube root. Then root 3, let's take a look at arrow 3. When we say root 3, we'll be saying arrow 3. Then the root 3 will be, let's say if we have a root like this, A over B, then this can be simplified by writing root a on top, as in you separate them over root b at the bottom. Root a on top over root b. Remember, the root was like a over b was a fraction inside them, but it can be separated. For example, if you like, you have 4 over 20 over 25. You have 4 over 25, okay, and you have a root that is covering both of them together. Then you can break it down by simply saying root 4 on top separately, and then root 25 at the bottom separately. Know fully well root 4, the square root of 4 is 2. Know fully well the square root of 4 is 2. You're sleeping. The square root of 4 is 2, and the square root of 25 is 5. So your answer will be 2 over 5. So you can separate that. This is the third rule for indices. Now, let's apply this. This is called sort. We are just introducing sort to your level. Okay, but also IGCSE you need this. Sort. So for sort, we can simply say, write this in the simplest square root form. Write this in the simplest square root form. So I will not write the sentence because we're managing space. Write this in the simplest square root form. So root 18. They've given us root 18. They say we should write it in the simplest square root form. So what we will do, we find the factors, 2 factors of 18, wherein one of the factors we can find square root, the other one doesn't matter. It could be a prime number. 2 factors of 18, in which one you can find square root, the second one could be a prime number. So 18, you already know the factor. The bigger one you can find square root, the other one is 9 times 2. 9 times 2 is 80, right? So you write 9 times 2. 9 times 2 is 18. So there you apply rule 1. Rule 1 says that when you have 2 numbers like this, you should put the root on each one. So the root will be root 9 separate times root 2 separate times root 2 separate. Root 9 separate and root 2 separate. Root 9 separate and root 2 separate. So remember, root 9, we can find the square root of 9, right? The square root of 9 is what? The square root of 9 is 3. Square root of 9, not the cube root, square root. Square root of 9 is 3. Okay? You say 3 times root 2. So this one, if we have to find this, we get 1 point something. So we'll just write it like that. So our answer will be, we leave it in sort form, 3 root 2. Because 3 times root 2 will become 3 root 2. We leave our answer like this, 3 root 2, in sort notation form. Okay? So this is how we simplify or we apply this topic to solve some problem. Now let's take a look at another one. Let's say we give you 80. We give you 80. Find the, we say write this in their simplest form. Simplest square root form. Write this in their simplest square root form. So we write root 80. So root 80, we're going to find 2 factors of 80 such that one of them, I know someone will say 40 times 2 is 80, but remember 40 you cannot find square root of 40. So since you cannot find square root of 40, we're not going to use that. We're going to find 2 factors of 80 where you can just simply find the square root of one of the factors, and the other one needs to be a prime number. The second factor needs to be prime number. If you don't know, see, it's easy. You do this division, 80. 2 goes into 80, you get 40. You can do this. But it's just that this one will take our space. No, 20 times 4, you cannot find square root of 20. But you can find square root of 4, but we want the larger one to be the one that we can find the square root. The larger one. Okay, what do I mean by that? 20 2 goes to 40, you get 20. 2 goes to 20, you get 10. 2 goes to 10, you get 5. Okay? 2 cannot go into 5. 5 goes to 5, you get 1. Now you see this, and this becomes 16. This is 16 because why? This is 2 times 2 times 2 times 2. That's 16. So 60 times 5 will give us 80. So you know we can find the square root of 16, right? So we break 80 as 16. Someone say 4 times 20. Yes, but 4, you can find the square root, but it's not the highest. You have to find the highest number with the square root. You still have to break it down and find like this, 16. 16 and 5 is a better choice than saying 4 and 20, because inside 20 you can still bring out a square root out of square number out of it. Okay, so this one we will break it. The next step is to break this one down singularly. So we have root 16 multiplied by root 5. Root 16 multiplied by root 5. So you find the square root of 60, it gives you 4. So 4 times root 5, 4 times root 5, you get 4 root 5. Remember, we're leaving the answer in root sword form. You get your answer to be 4. 4 root 5 means 4 times root 5. You leave your answer like this, 4 root 5. This one must be a prime number. Remember, why we did choose 4 at 20 is suggested by one of you, is because this is not a prime number. You find one number that you can find the square root, the other one must be a prime number. You know prime number, right? Number that has only 2 factors, itself and 1. So the second number must be a prime number. This one is not a prime number, so we cannot use this. So every time you break the number down and find the maximum of the root, the one you can find the root, join these factors, 2 times 2 times 2 times 2, as much as you can get a square root. And then the other one, once you get a prime number separate, then you use it quickly. Is that okay? Meaning we're looking for one number we can find square root and a prime number as the second one. It makes the problem easy for us. Is that okay? Now, in this case, they want us to find root 50, number 3. However, they've given us the value of root 2. They say find root 50. Find root 50. But they've told us, given that root 2 is equal to, square root 2 is equal to 1.414. Given that root 2 is 1.414. So they've given you the value of root 2. This one they don't want you to leave the answer in sod. So they've given you, in case you have your answer ended with root 2, you should take it as 1.414. So remember, 50 is easy to find. 50 is 25 times 2, because we can find the square root of 25, and 2 is a prime number. The second factor, which is 2, is a prime number. So we need a square number and a prime number. A square number and a prime number. Are you with me? The simplest prime number. The simplest prime number. As small as possible. 2, 3, 5, 7, all those type of prime number should be the second one. Okay? So now 25, this is simply, you separate each one with its own root. First, if you have a root for all of them, for both of them, you now separate individually. Root 25, that's the next step. Multiply by root 2. Multiply by root 2. Okay? So root 25 is 5. If you find the square root of 25, is 5. In part 1, we learned how to find the square root using this method, right? The square root of 25. How do you do that? You know 25. How do you know it's 5? Just to refresh your mind. Okay? You say root 25 is 5 times 5, right? 25 is 5 times 5. Is that okay? So we say for 2 factors you take only 1 as the square root. For every 2 factors you take only 1 as the square root. For cube root, for 3 factors you take 1. For cube root, for 3 factors you take 1. For square root, for 2 factors you take 1. So since 25 is 5 times 5, to find the square root you just merge and take 1. So the square root of 25 is 5 times root 2 times root 2. So you have what? Remember, they've given you the value of root 2. This time they want you to find the number. So you say 5 times 1.414. So you press your calculator. This one they want you to press. 1.414 times 5. 1.414 multiplied by 5. Then you get 7.07. 7.07. Okay? If they give you the value of this one, then you can find the number. Is that okay? Okay, quickly. Now, what if they give you something like this, something different? Now we want to try something different in applying this. We want to try something different. We want to try simplifying. It says simplify this one. Are you with me? Simplify root 2 into, you open a bracket. Then another root 2 here, plus root 8. Plus root 8. They say we should simplify this. Okay, you see, once you have something like this, means what is outside the bracket, we first of all multiply what is inside the bracket. So I'm going to just go straight because of the number of space that we have to write, number of words we have remaining. So I'll just say root 2 times root 2. What do you get? I'll write the answer. Normally I'm supposed to write root 2 multiplied by root 2. But you already got that. Root 2 multiplied by root 2, you get what? Root 4. Am I right? I jump one step. I'm jumping one step. Okay? For this simplification, I'm jumping one step. Then plus root 2 multiplied by root 8. Root 2 times root 8 will be root 16, right? It will be root 16. Root 16. Right? So let's break each one down. If I find the square root of this, I will get what? Or you can do another method. You can say 2 to the power of 2. The square will cancel, square root 2 will remain. Or simply you just say the square root of 4 is 2. Then plus the square root of 16 is 4. Then that leaves our final answer to be 6. This leaves our final answer in this question to be 6. Is that okay? Is that okay? Now let's take a third rule now, the one that involves a third rule. Okay, after this third rule, then we end the class. Okay, let's take a third rule. A third rule, the one that involves the third rule. Let's say they want you to simplify this one. 72 on top over 20 at the bottom. 20 at the bottom. They're together with one big root. Remember, this was for the third rule. When we measured the third rule, I wrote the third rule 3. When I say A over B, or with a big root, root 3. Okay? The one we solved just now was for root 2. When we use something to multiply inside the bracket. Okay, we've done root 1 before. We've applied problems to root 1 before. Now let's apply root 3 now to this question. Let's apply the knowledge of our root 3 to this question. Remember, we said if you have this, the first step is to split. You write root. You write so we have root 2 over root 72 over root 20. Okay, let's be fast and finish it. We'll end it with this over root 20. So we can now break them down. You know 72. You find two numbers when you multiply. One will be a square number, the other one will be a prime number. One will be a square number, the other one will be a prime number. Now the square number will be what? What are the square number? Who can tell me the two roots? Who is so fast? This will be 36. 72 is 36 times 2. Okay? 72 is 36 times 2. Because the 36 is a square number. So once you have that, the denominator 20 is 4 times 5. 20 is 4 times 5. Why do we choose 4 times 5 for 20? Because 4 we can find the square root, 5 is a prime number. 4 we can find square root and 5 is a prime number. The next step is to break each one individually. Root 36 times root 2. All over the bottom, you have root 4 separate times root 5 times root 5. So the next step for us, what's the square root of 36? We get 6, right? So 6 times root 2 is 6 root 2. 6 times root 2, we get 6 root 2 at the top. All over the bottom, what's the square root of 4? You get 2. 2 times root 5 is 2 root 5. So our answer will be 6 root 2 over 2 root 5. Right? 6 root 2 over 2 root 5. Is that okay? But if you're given this question, we are given the value of root 2 and root 5. If you're given the value of root 2, this will be 6 times 1.414, which is the value of root 2. And then the value of root 5 was also given in this question, though we didn't write it down. The value of root 5 is 2, so we write 2 times. The value of root 5 was 2.236. 2.236. So if we do the multiplication out, we will have the final answer to be 1.90. Final answer. You simplify this one out. The final answer will be 1.90. That's our final answer. Okay, so this is where we stop for today. Thank you very much for joining us.